Hey everyone, and thanks for watching. My name is Megan, and today I will take you on a tour of the archaic past recorded in the Upper Peninsula with a focus on 3 outcrops. Before we get started, I wanted to give a brief refresher of the Archean Eon. The Archean Eon takes place during early Earth times, geologically labeled as the Precambrian. The Archean is estimated to have taken place between 4 to 2.5 billion years ago and is generally divided into 4 subgroups. Today's featured outcrops have been roughly dated to have occurred 2.7 billion years ago, placing them in the New Archean, ranging from 2.8 to 2.5 billion years ago. The end of the Archean leads into the formation of the first supercontinent known as Land. Now that we have our time frame in order, let's begin our journey. The Upper Peninsula, painted red, is located in the U.S. Upper Great Lakes region on the southern edge of the Superior Province of the Canadian Shield. The Superior Province is one of the largest segments of Archean crustal blocks, making it an excellent proxy for the reconstruction of Archean history. The Upper Peninsula is attached to the state of Wisconsin, though it is defined as part of the state of Michigan. It is in contact with 3 of the Great Lakes: Lake Superior, Lake Michigan, and Lake Huron. The white dots denote major cities in the area, and the green dot features the city of Marquette, as well as the locations for our 3 outcrops. Let's first get a brief overview of the Upper Peninsula in terms of tectonic and bedrock history. This is a rough tectonic map I reproduced from Bauer et al. 2011. Our field location is denoted by the red star. I would first like to direct our attention to the north. Looking at the lithologies, we can note stripe-like patterns in their deposition. This pattern and variety in lithology represents the Upper Peninsula's long and diverse history, from the accretion of island arcs through active boundaries and to passive margins, which would deposit sand and other sedimentary rocks. Analyzing lithologies and their deformation help us reconstruct the geologic past. Now that we have a broad overview, let's focus in a bit. Here we have a map showing the major tectonic events, otherwise known as orogenies, in the area. This map was reproduced by my classmate Kyung-Do Han, which was compiled by T. Borboom and the NICE Geo Group 2006. Our focus location is again denoted by the red star. Looking at this map, we can see that the area has gone through various tectonic events ranging from 3.5 billion years ago to 1 billion years ago. The Upper Peninsula has been heavily impacted by the Pinokian orogeny that took place from 2.3 to 1.77 billion years ago. Remember, our field locations are Neo-Archean in age, which are 2.7 billion years old, so the Pinokian occurred after their deposition. The Pinokian affected the outcrops through fractures, deformation, and intrusions. We will see them later in detail in this video. Now let's move on to the bedrock geology. Here's a rough map showing the geologic bedrock of the entire Upper Peninsula. As you can note, there are an array of bedrocks ranging from igneous metamorphic lithologies to dolomite and limestone. This is due to, again, its very tectonic history. Our outcrop locations fall within the region of igneous and metamorphic bedrock, featured here by the green circle. Igneous bedrock is to be expected because the Neo-Archean was a time of high volcanism. The metamorphic lithologies document the tectonic evolution of the Upper Peninsula throughout time. Finally, let's take a look at our 3 stops. They are located in close proximity to each other in the Marquette area, showing similar features, yet record different events. Our main area of focus will be on the greenstone belts, which are metamorphosed to monoschist, and basaltic bodies, including pillow basalts. These outcrops are all part of the Ishpeming Greenstone Belt. Field stop number 1. I will always refer back to our location map before each stop, just so we keep track of our location. Each location will now be denoted by a red star, and our other locations will be downgraded to the color yellow. Bottom right-hand corner gives the exact GPS coordinates and a verbal description of the location. Stop 1 is located across the road from the Lakeshore Welcome Center. Pictured here is an excellent view of field stop number 1. To the left, we see the monoschist, which is Archean in age. And all the way to the right, we have the Maynard quartzite, which is Paleoproterozoic in age. What brought these two time periods, the Archean and the Paleoproterozoic, together? The answer is the Great Lakes Tectonic Zone, which is abbreviated as GLTZ. The GLTZ is noted to have accreted two separate terrains of different time periods. It is not very well featured in this outcrop, but we know it is here because it juxtaposes the right lithologies, the monoschist and the Maynard quartzite. It is also characterized by a zone of mylonites, which was found in abundance at the base of these two rock formations. What we do see here, featured very nicely, is a fault. This fault is quartz-rich and became an excellent conduit for hydrothermal fluids to intrude and hydrothermally alter the rocks. The monoschist is a hydrothermally altered greenstone. What is a greenstone? A greenstone is a metavolcanic, which was likely derived from an intermediate to mafic rock. Greenstones are some of the oldest outcrops to date on Earth and are a great indicator for understanding Archean events through their deformation. Greenstone belts are dominant terrains in the Superior Province, forming in abundance around 3.6 to 2.6 billion years ago. The tectonic process that created greenstone belts are still widely debated amongst geologists, with the most plausible theory as a mixture of both vertical and horizontal tectonics happening simultaneously. Modern tectonic mechanisms are not thought to have officially occurred until 2 billion years ago at the latest. Why the greenish tint? Chlorite is an index mineral for hydrothermal alterations. Chlorite is a mica and gives off a greenish hue that can be seen in the rocks. If we zoom into specific parts of the outcrop, we see crenulation cleavage. Crenulation cleavage is a rock fabric most commonly seen in rocks rich in micas such as schists. They are created through metamorphic alterations. This outcrop also displays what is known as SC fabric, which record deformation information. Stop number 2, Lighthouse Point. Before we start, it should be noted that to visit this outcrop, you do need permission by the Coast Guard station. Even though this may seem inconvenient, it is definitely worth it. It is an absolutely beautiful place. With that in mind, let's move on to the rock types at this location. There are many rock types recorded at Lighthouse Point that are featured as intrusion/dikes. These intrusive rocks are basalt/diabase, microgranites, and metadiabase. These rocks all intrude the monoschist, which we were introduced to in our last field stop. The monoschist has been tilted vertically and has been heavily fractured by the Pinocan orogeny, occurring roughly around 1.8 billion years ago. These fractures created large spaces, allowing for igneous intrusions and hydrothermal alterations. Further evidence for hydrothermal fluids is seen in quartz inclusions, which are not featured in this video, but can be seen in abundance in the outcrop. The massive basaltic intrusions are blocky and more cohesive than the monoschist, making them easy to distinguish them as separate. This is a close-up image that shows just how distinctive these intrusions appear at the outcrop. It's pretty amazing. Here's an added picture to again revisit the vertical bedding and fractured surface of the monoschist. And for the last stop of the day, we're going to look at some pillow basalts located across from Shunk Furniture Store. These pillow basalts are part of the Ishpeming Greenstone Belt, just like field stops 1 and 2. Pillow basalts are created by the extrusion of lava that must occur in a marine setting, creating these pillow-like features. They were most likely formed in an island arc setting, then later accreted to the southern edge of the Superior Province. Let's take a closer look. Here we have zoomed in a picture of a single pillow. I have labeled the convex top and the cusp. Think of pillow basalts like balloons. They are essentially getting blown out of the earth like one would blow up a birthday balloon. Because they formed in a marine setting, they will remain balloon-shaped due to fast cooling rates. The interior of a pillow will have larger crystals than the exterior. The exterior of the pillow cools rapidly because it is in direct contact with the cool water, while the interior cools at a slightly slower rate, creating this variation in crystal size distribution in the pillow structure. Back to our diagram, the top of the pillow is convex in shape and most feature small vesicles lining the exterior of the top. On the other hand, the cusp will be more angular in shape. I have also noted the elongation of the balloon-like feature. This is due to deformation. The pillow most likely deformed, thus elongated while agreeing to the superior province. Understanding the orientation is critical in being able to reconstruct their formation via their labeled identifying features. So what is their orientation? I have reposted the exact same picture from the previous slide and have now traced out the pillow structure. Hopefully, when you flip back and forth between slides, you can note the pillows by yourself. We know that their features are directed northward due to their cusp and top orientations. These pillows have not only been elongated, but beds have been vertically tilted, another factor to take into consideration while conducting fieldwork on pillow basalts. Deformed pillows can get a little tricky in the field. And to answer your question, yes, a deformed pillow basalt is just as comfortable as a non-deformed one. I wanted to again just briefly state the diverse history of the Upper Peninsula through various features, especially the varied stratigraphic past. We focused on the Archean, but the Paleoproterozoic records the Marquette supergroup, which is further subdivided. With that said, the Upper Peninsula is a great study area to understand the geologic history of the past. We only looked at a fraction of the history, focusing solely on the Archean. These are my resources as well as using my own personal field notes. I'd like to specifically note the article, Archean Ishpeming Greenstone Belt and Gold Mineralization, Michigan by Johnson and Bornhorst, 1991. With that said, thank you so much for watching, and I'd like to give a special thanks to all my classmates who took this trip with me.